Good afternoon and welcome to another instalment of Cork Does Maths. An exciting one today. We're looking at angle chasing again, but this time in circles. Okay, I'm going to draw some circles here, and we're going to look at the circle theorems that we did from last time, but very briefly. This one, we know that we have a diameter. The angle subtended from the diameter is 90. That's 90 degrees there. The next one, when we have an angle subtended from the centre, that will be double the angle subtended at the circumference. We call this the arrowhead theorem. Okay, this is the batwing theorem if you remember. Now, angles subtended from the chord are always the same, so that means that the green angle and the red angle there are the same. This one's simple. The tangent meets the radius at 90. Here we have the alternate segment theorem. So those two angles are the same. Okay, if you don't remember that, then look it up in the other video. And finally, oh god, go back, okay, and finally there, this here is the cyclic quadrilateral kind of theorem thing. So opposite angles and cyclic quadrilaterals add up to 180. So those orange angles there add up to 180 and those green angles add up to 180. So we're going to look at how to apply this to questions. Example 1, got a circle, we've got this triangle here, and we've got this value. You see how that's x and that's 5x. Right. So we need to decide which theorem we're going to use. The first thing we can say is that, well, this is a tangent. So we know that tangents meet, if you look at where I've underlined that orange bit there, we know that tangents meet the radius at 90. Okay? So we know that that is 90 degrees there. Carrying on. That means that x plus 5x plus 90 is 180 because they're angles in a triangle. Simplifying the left-hand side gives us 6x, and take away 90 from both sides means that 6x must be 90, so x must be 15 degrees. Done. We know what x is. That was our question. Solved. Boom. Example 2. Okay, draw a circle. This is the question. I'm just phrasing the question. By the way, the first word is fairy. Okay. Right, so we've got this angle here. We're told that that's x. This one's y. This one we're told is 78. Okay, so this is the question. Now again, we can use the theorem that's underlined there in orange, that tangents meet radii at 90 degrees. So we know that the total there is 90. So that means that x plus 78 is 90. Okay? So that means that x is just 12 degrees. Right, now how do we find y? Well, if you think about what we've done in the last couple of lessons, we were looking at triangles that look just like that pink one there. Just like that pink one. They're isosceles. So that means that this angle here, those two lines are the same length, those two angles are the same, so that means that that is also 12 degrees. That's an isosceles triangle. Okay, that means that y plus 12 is 180. So y must be 118 minus 24, which is 156. Great, done. So we found x, we found y, question done. So far we've only used ideas from lessons and tangents meeting radii at 90 degrees. Right, example 3. This is the question. Okay, this is a very easy question. We can look at the arrowhead theorem straight away. So the arrowhead... Oh, by the way, the time is 4:08 p.m. Okay, the arrowhead theorem. This is the arrowhead theorem. So, angles at the circumference are half that of the centre, or angles at the centre are double that of the circumference. That just means x is 56. Boom, done. Very easy. Next. Okay. So we've got this diagram here. Now this is the arrowhead theorem, it just doesn't look like an arrowhead. The angle at the centre is double the angle at the circumference. So that means that, I'll just write that arrowhead, angle at the centre is double the angle at the circumference. So that means that x is just 105 degrees. Finished. Boom. Question done. Okay, write that out. Next example, example 5. Oh, let's go back. The subject you're looking for is science. Okay, this is the question, this is given to you, this is the diagram. Let's go back a bit. Let's go. So that's the diagram there. That's the diagram there. Now notice how, firstly, we've got an equilateral triangle there. We'll come to that in a bit because we know that those three sides that are marked are the same length. So that's an equilateral triangle, that small triangle there. Okay, now the big triangle. So the big triangle looks a little bit like that triangle there. So that means that the angle at the top is 90 degrees because the bottom line goes through the diameter. That is the diameter, so the angle subtended from it is 90. Okay, looking at the angles in this small triangle, we can say they're all 60 because it's an equilateral. That means that that angle there left over is 30, because 90 take away 60 is 30. Okay, now this is very similar to the previous page. We can say, well, that angle and that angle are the same, because if you look at that triangle, it's an isosceles triangle. It's got two radius. It's an isosceles triangle. So that means that x is 30. So that's the ideas from the lesson. We've kind of done that. Next example, example 6. Draw this triangle. Okay, we're given this angle is 88. We're given that angle is 40, and our job is to work out that angle. Okay, right. Now I've kind of underlined it. Hopefully you might have seen that. So this looks a bit like the Batwing theorem, and it is the Batwing theorem. Okay, so that means that before we start going into this question, the year is 1972. Carrying on. So using the Batwing theorem, then that top angle is also x. Okay. Those two x angles are subtended from that chord. Okay? We can look at that triangle now. Now we know one of the angles is 40, one of the angles is 88, so what does that mean x is? Well, x is equal to 180 minus 40 minus 88. Okay? So that was... I can't read that, 52. That's 52 degrees. Okay? So in that question we were using the Batwing theorem, and we were using angles in a triangle. Next. Example 7. Okay. So this is what we're given. We're trying to find x in this question. Now, right, what do we know? Well, we know the theorem, we know about cyclic quadrilaterals. This is a quadrilateral. It's a cyclic quadrilateral. So opposite angles in a cyclic quadrilateral add up to 180. That means that angle there must be 113. Yeah? So x, well, there's a triangle there. There's a triangle there. If I just highlight that triangle now, we've got this. Okay? That triangle, so we know that x is equal to 180 minus 32 minus 113. When you do that, you get 35 degrees. And the final word is tiger. Okay. So let's just recap on what we've done. We've used most of the theorems. Okay? We've used the theorems when we're angle chasing. We can say certain things about these questions because of the circle theorems at the top. The only circle theorem we haven't used is the alternate segment theorem. We'll go into that in lessons. But in lessons, over the next couple of lessons, what we're going to be doing is just doing some angle chasing. Okay? Just using the ideas from these two videos to do angle chasing. You see how easy it is. You just need to know and be able to apply these skills. It's just some new maths. I hope I've tried to make this video quite quick, and I hope it was as enthralling as it was to make. So I'll see you tomorrow in lessons, and I'm expecting lots of homework done, etc., etc. Thank you for watching. Great to have you on board. Have a great evening. Do something nice for your mum later. Maybe do the washing up, tidy your bed. Don't play games before bed. Have a great evening.